Welcome back. Our essential question today is how do I solve quadratic equations with complex roots? As you can see, this is a day 2, so we're going to kind of just go back over something that we already talked about. So Miss Young, go ahead.
Okay. So what we talked about yesterday was, again, complex numbers. And complex numbers can be written as in the form a plus bi. Remember, I is imaginary. And so we always talk about the real part and the imaginary part. Students get confused because they want to call the imaginary part bi, and that's not the case.
No,
it's just b. What happens is a by itself is a real number, and it's a real part because there's nothing multiplied by it. B by itself is a real number. When you multiply it by I, it becomes imaginary. That's why b is the imaginary part.
Okay.
All right? So now we're going to go on and notice what we're doing on the next page. Let's see. There we go. There we go.
Okay.
Remember 5.5 day 1?
Yep.
We started it saying we're still finding the zeros, the roots, and the x-intercepts. Still thing.
Okay. So there are different ways we can do that.
Right. However, they're not going to be real solutions this time. They're going to be non-real. Right. We're going to have get a complex number, imaginary number.
Gotcha.
So when we find the zeros in the last while ago, what did we always do? We set what equal to 0? We set the whole function equal to 0, so we do that. And the first thing I thought is let's try to factor it.
Okay. Any numbers that multiply together to give us 13, but add to give us 4. Well, the only numbers that I can think of are 1 and 13.
Right.
There's no way we can add or subtract 1 and 13 to get 4.
No. So
we can't.
No, and I always say let's try factoring first
because it's easiest.
Right. But if it doesn't tell you a method to use, you don't have to factor.
No.
In this case, we can't. Right. So if you can't factor, your next option is completing the square.
Okay. So that's all of our x's on one side.
Right.
So I'm going to subtract the 13. So I get negative 13.
And remember,
I'm going to add
something. Yes.
Equals to x squared plus 4x plus something.
Right. And that plus something, remember, is b over 2 squared.
All right.
So we know that
b is 4.
Right.
So 4 over 2 squared is, well, that's just 4.
Right. And so that's what we're adding to both sides.
To both sides.
So negative 13 plus 4, that's a negative 9. And now remember what we do on the right side? Now we can factor that because now we created a perfect square. That's what completing the square does. So it's going to be x plus 2 and x plus 2. Remember, when you complete the square, you factor it, the binomials are going to be the same. So there's 2 of them. And now we take the square root of both sides. But notice, right, so what?
Oh, now we have a negative.
Right, so I'm going to try to scroll down for you here a little bit. There we go. So what happens right away, they're going to start jumping to, I mean, we can break it up into the 2 parts maybe this time.
Okay.
Because it's really going to be what? Square root of 9 times the square root of negative 1.
Plus or minus.
Yes, sorry about that. Yes,
sorry.
I apologize.
I just wanted to quickly do that.
I'm sorry.
So we're breaking this up into plus or minus.
Yes.
Square root of 9, positive 9, and square root of negative 1.
Right.
Equals x plus 2.
So now the square root of 9 is
3.
So you have plus or minus 3, and that just becomes I.
Oh yeah.
Let's jump right to that. Just
equals
x plus 2. Well, guess what we're going to do?
Subtract 2.
Subtract 2 on both sides.
Move this over.
Yes, because remember,
so this is going to come up here.
Remember back in completing the square, whatever gets moved over always is written first. So negative 2 plus or minus.
I'm going to change that. That doesn't look too good.
Good idea.
Thanks. And then we have 3i.
Yep. And that is it.
That's our answer because we can't combine a negative 2 with a 3i because the I is attached, kind of like an x.
Right. So let's circle that.
That's our answer.
So let's see. Should we wait? Should we skip this one?
Well, let me see what's on the next page.
Yeah, let's go to the next page and just look at the next page really quick.
Yeah, let's skip one of them.
Let's do this one.
Let's do this
We'll
one.
skip example 2 and we'll go to example 3. Same thing. Find the zeros.
First thing, set it equal to 0.
And I always like to try factoring first.
Me too.
So the only two numbers that will multiply to 5 are 5 and 1,
Right,
and 5
those
and 1 will
counts.
never add or subtract to get to
All
negative
right.
2, completing the square.
So subtract 5.
Mm-hmm.
Subtract 5. We get a negative 5 equals
Plus,
x.
don't forget the plus on the line, because we know we're completing the square. Negative 5 plus.
Oh, sorry.
Remember?
Already forgot that.
Mm-hmm.
All right. Negative 5
Mm-hmm.
plus something equals x squared minus 2x
Plus something. Well, that something is b over 2 squared.
All right, and our b this time is negative 2.
Right,
So negative 2 over 2, which is negative 1,
right.
squared gives
Is
us
1.
1.
That's what
So
you're
we're
adding to
gonna add
both
1
sides.
To both sides.
Well, negative 5 plus 1 is
Negative
negative
4.
4, and now we're going to factor the right side
Yes. Which
into,
is just
yep, a binomial, x minus 1 and x minus 1.
Because negative 1 times negative 1 gives us 1.
And
Negative
they
1
add,
plus negative 1 gives us negative 2.
right.
So we get the negative 4 equals x minus 1 squared.
And now we're going to
Square root
take
both
the square root of
sides.
both sides.
That's going to cancel.
Yeah, and I scroll down for you.
So I'm going to get plus or minus
Mhm.
square root of negative 4 equals x minus 1.
Right. So now we have to break that
this up.
apart.
2 square root of 4 and
Square root
square
of
root of
negative
negative
1, and the plus or minus stays with it.
so I'm going to do plus or minus 2
I equals,
x minus 1. I'm going to move it up again because when I add 1,
to both sides.
the 1 is going to come out front now.
Plus or
minus
minus 2i. And that is your answer.
Sweet.
Nice. All right, let's scroll down. Let's talk about the word complex conjugate. So look at those two solutions.
Mhm.
Negative 5 plus I root 10 and negative 5 minus I root 10. Notice their real parts are equal, negative 5 and negative 5,
Mhm.
and their imaginary parts are just opposite of each other. One's positive and one's negative. That is what happens with a complex conjugate.
Okay.
Okay, so when you're, a helpful hint, when you're given one complex root, you can always find the other one by finding its conjugate. That's
Okay.
it. So let's practice.
Okay.
Here we go. Find each complex conjugate. Now, what I like to do right away, before I find the conjugate, I want to make sure my real part is first and my imaginary part is second.
Okay.
So 9 minus I, that is in the correct order.
Right.
So to find the conjugate, all you have to do is change.
You keep this.
Yes. And
we
you switch
change
that.
this, so now it's plus I.
That's it, you're done.
oh my
That's a
goodness.
complex conjugate. So easy.
That's easy.
Now look at B. Notice the imaginary part comes first. So let's rewrite
switch
that.
the order.
Mm-hmm.
So square root of 3 plus I.
Right. So now the complex conjugate is you change
Square
the
root of 3,
imaginary
we
part.
keep,
Yep.
and now we're going to subtract I.
You're done.
Oh my god, this is
Isn't that easy? But look at
Yes.
this one now.
Okay.
So I see negative 8i. The real part has to be first, but I don't see a real part. So it's probably going to be, yep,
Right?
right.
Awesome.
So okay, so did you right away wrote the answer, right?
Well, okay.
Okay, you better-
So I meant.
yep.
Yeah,
You
I was
see what I
doing two
mean?
things at
Yeah.
once. So really, it's 0 plus, or
0
sorry, 0 minus 8I.
And the
0
conjugate,
stays the same.
yep. And you,
So then we change the imaginary, which then just makes it a positive.
yes,
8i.
I just thought we better show all those
Yeah, good
steps
call.
just
I
in
was
case. Next page.
Oh,
Wow.
easy.
8 minutes and 51 seconds. Okay, so find the zeros of the function,
You can do that.
and they probably can't be factored, but you can sure try. And find the complex conjugate. With that, we
But
will
careful
oh.
because the imaginary is first, so switch it.
change the order.
All right.
Yes. See you tomorrow.